All right, so this is a talk about what I have in production and what you should probably not do in production. It is a story of making bad decisions. It is a story of taking complicated pieces of software like browsers and putting them in limited computing environments. So let's go. Okay, so first off, who here has used a serverless environment at any given point? It does not have to be in your production environment at work. Cool. Okay, so for those of you who are not really familiar, because it isn't that new of a term, but it's not also that common, you can think of them as functions of as a service. So you can write a bunch of code. Hopefully it's not that big. Decide what triggers you want it to run because of, and then deploy it. And hopefully you don't have to configure too much. And the idea is that it's just, you write a function and then it just magically works. So these are three of the main providers that have a serverless offering. And implementation details matter quite a lot in this space because you have almost no control. So you have to pick one. Honestly, I recommend going with whatever cloud provider you have already. So almost everyone is going to go on Amazon. But if you did need to write a talk like this one and therefore have to have an opinion, you could read a paper like this one. I found it fascinating that you can actually get a grant to research serverless computing for your real job. This is a real paper. They were genuinely paid. They are actually researchers. Who knew? So I learned a bunch of things from this paper. First of all, go with AWS. If you don't already have a cloud provider, just let's stick with what we know. They had the most clearly matched docs to observed performance. They had the shortest response time to trigger the function. And those are two really good reasons to just stick with that. The next thing that I got out of this paper is that serverless is not as intuitive as you might think. We all kind of understand how a server works, how a virtual environment might be useful, but how the details work and how everything interacts in a complicated situation, maybe not. So the researchers who wrote this paper had honestly made a bunch of assumptions that they couldn't correctly validate. So then they realized that there was a completely different model than the way they were thinking about it. For example, any of the functions that you might be running concurrently are going to have resource competition with each other, which is completely unexpected if you just think of it as not my job to worry about the infrastructure with serverless. Another thing, this paper really brought home that serverless is still a really brand new thing in the computing world. AWS released their offering in 2014, Microsoft and Google 2 years later, 2016, and both of those were like the earliest possible release that you as a general person could use in beta. So they've been rapidly iterating and improving so that they can save you and themselves as much money as possible. But that means that all of the things that you know about it are somewhat incorrect as everybody is moving forward in time. And finally, definitely recommend reading a paper like this because companies are motivated to mask all of this information that they don't necessarily want to tell you. If they expose too much information about their environment, they can no longer change it. And that means that they're stuck, and that is terrifying. And also, I highly recommend reading a paper that sort of conglomerates these things because all of the companies have decided on words that mean something in their environment, but they mean nothing in the environment that you might be using. So if you're reading AWS docs and then you want to compare that to a feature in Azure, you won't be able to figure out what the words are, and that can be really frustrating. There isn't an open source community that's decided on a set of vocabulary. Okay, so why am I here? How did I get here? Well, in December 2017, I was in startup land, which you can all imagine is a place where things just happen that you don't necessarily love as a developer or as an ops person. They just have to get done. That's more important. So I was told, we need a scraper. Great, okay, no problem. Scrapers are fun. But we can't make any new infrastructure. So just stick with what we have. There's no fancy tools here that you can use. Whatever we have is what we get. So you can imagine my face at this point. So the website that we were going to scrape used a bunch of JavaScript to do all sorts of stuff, interacting with the DOM. If you want to do any sort of web scraping and you need to run in JavaScript, you basically have to use some kind of browser. Whether or not it's a Chrome instance or something else, you are kind of stuck, unless you would like to write your own browser. I highly do not recommend this path. Manipulating the DOM is the job of the browser. So when you load a page, you are going to create, or the browser will be creating an object model of what the page is supposed to look like so that they can render it effectively. You should not ever want to write your own DOM rendering, DOM building thing. So that was out. Can't write any custom software. OK. The other options that we had were to use a bunch of self-created automating headless browser tools. So these are Casper and Phantom.js. And both of them were just designed to be automatable browsers. So they were supposed to be as simple as possible so that you could throw them anywhere and do whatever you want and not think about it. Unfortunately, even keeping up with the features in any given browser just as an open source project takes an extensive amount of community support. So as soon as Chrome released Headless Chrome as a thing that you could use at some point in the last year, that was it. You had no possibility to find anyone who said, yeah, let's keep working on this headless browser that doesn't, like it's not Chrome, so I can't use it for any UI testing. So what's the point? Let's just stick to Chrome. So luckily, Chrome also, when they decided to release Headless, released a tool called Puppeteer, which is their way of saying, we don't like Selenium as a dev tool. Let's write our own thing. Then we don't have to have quite as many different pieces of code running around. So what it's doing is creating a bunch of HTTP requests that it is sending to the browser, and then the browser is saying, OK, this means I should follow this instruction, and then it will send a response back to your scraping process. So back to my situation, we had no task servers. So if you want to run a scraper, you probably don't want to run it on the side end of a web request. So if you are just triggering it and then letting the user wait for another web request, parsing the response, and then sending it back, that's no good. Don't do that. So you probably want a task server so that you can delay the response. We didn't have any of those. We literally just had Lambdas. That was our option. So at this point, you're just thinking, this is a terrible idea. You've said the words Chrome and Lambda, and you're going to do this. This is bad. Especially, this is a bad idea because serverless environments are designed to give you as little control as possible. This is great for the developers who work on these serverless platforms because then they know kind of what parameters they're optimizing you for. But they're going to give you a bunch of limits, and you have to fight them to make any sort of crazy thing happen. So AWS gives you a bunch of random numbers that they say, you have to pay attention to these, and if you go over this limit, you're out of luck. So these are in the AWS docs. They give you between 128 to 3,000 megs, and that's it for RAM. Cool. You can do a lot of things with that much RAM. You know, you're not completely dead in the water yet. OK, but what about how long you can run this task? This is actually a really long time. 15 minutes of task. This is, I think, much longer than it used to be, but 15 minutes of code execution in one task. Those are pretty long. So this is actually good news. OK, but you can only upload a zip file of up to 50 megs. So all of the dependencies, all of the code that you have, and anything else that you might need in this computer, the only way you can get it in there is if you can zip it to a 50 meg zip file, and then you can upload that. Additionally, when you unzip that file, or when anyone unzips the file, it has to be less than 250 megs. So this gives you some limitations. I bet you're all thinking right now, OK, well, Chrome there's no way Chrome fits within these limitations. Like 250 meg binary of Chrome, there's no way. So we'll talk about how we get around that in a second. So one of the problems with serverless is that functions, the way that we conceive of them, are intentionally very ephemeral. They're not supposed to leak any sort of state externally other than returns, unless you're not running pure function style coding. But let's pretend we all live in a purely functional world. You don't get the internal state of the function. And this is true very clearly with Lambdas. So the only thing that is different and completely unexpected is that they share the global scope. So this should give you a bit of a pause, because let's say you have something that you don't want to create every time you run a function. Let's say normally in a way that you'd write this, you'd write it so that it was caching it somehow, maybe calling out to Redis. You, with a Lambda, are going to just declare this in the global scope. And this is true for Google as well, Google's serverless platform. Azure, I think, does it a little differently to give you access to shared resources in between functions. But the first time that your code runs in the Lambda, it's going to execute anything that's in like the global scope. So it's not wrapped in a function. It's just going to run. And then subsequent executions that share the same context. So Amazon has decided, yeah, this looks like it's fine. We can just reuse this. It doesn't look terrible. They won't run this code. They'll just use whatever the process previously had when it exited. And they're just actually just freezing the context that the function is running in. Side note, if you change any of the environment variables, this forces a cold restart of your Lambda. So they will run this the next time, which is great, because a lot of the time that's what you probably are using to set configuration issues. So this probably scares the crap out of a lot of people. You can't define any sort of infrastructural way to tell the AMI that's running the Lambda what it should have installed. You just get the most vanilla AMI AWS provides, and that's just what you get to run your code, which turns out to be great, because you just put everything in a zip file. Everybody knows how to debug a zip file. They're super easy. You can just point people at your build artifact, and it's just a bunch of files. This is fantastic. A cool feature that I think is interesting, Google and Amazon or Azure will also take any standard package manager file, so requirements.txt or package.json, for example, and they will actually install all of the code or all of the dependencies that are involved there as well. You can just do that yourself if you wanted to. With Azure or AWS, you are required to. They have no interest in dealing with your package manager for you. One final note on serverless limitations. All of the tools that you are used to using don't quite work with a serverless sort of environment anymore. So like all of the cloud-provided tools, CloudWatch, et cetera, do work. But if you're used to being able to SSH onto a box, I mean, I hope you're not doing that already. But if that's what you're used to in a time of need, you can't do that on a serverless function, because it will not stop and wait for you to be ready to execute any commands. There's no command line access. This mainly means that you end up learning print debugging again. So if you hate print debugging, maybe skip the Lambdas. So all of that sounds crappy, right? But you do get a bunch of great stuff with this. You don't have any control, but that means you don't have to do very much work. You kind of just have what you get is what you get, and you don't get to be fancy. It is somebody else's job to manage scaling. This is amazing. I don't want to deal with this. I'm a developer. I do not want to think about where my code is running or whether it's running or how much it's running. I just want somebody to deal with this for me. And when I have to interface with someone in ops, they will have opinions about, well, we don't really need to be that fault tolerant, or we don't really need that many more servers. It will cost us a lot more. This auto scales up to 1,000 concurrent executions at any one time, and you just don't think about it. If you hit that limit, you're probably screwed, but you're also probably a really large company, or you're doing a lot of weird stuff in the Lambda and running them all for 10 minutes, 15 minutes at a time. So this is great. So I just want to compare serverless quickly to a do-it-yourself approach. So you have the logos here of RabbitMQ and Celery, So if you combine those two, you more or less get an equivalent version of a function runner and SNS-style messaging, because RabbitMQ does message brokering, and Celery is an async task queue. So if you want to go this route instead of the serverless route, someone has to learn how all of these pieces run together. There are a lot more moving parts. And Celery's default, which I had to learn the hard way, is that Celery does not log any exceptions. So you will have all of these logs saying, yep, console.log or whatever, or print whatever, and then all of a sudden there's an exception and it's completely silent. Even though the log level says, hi log, log everything. How do you troubleshoot that? How do you know that in advance and then not put that in production? Lambdas are designed intentionally by a product group to make sure that you don't hate them after you just pick it up for 30 seconds. So someone else is on your side. OK, so I mentioned earlier, browsers are complicated. Chrome has a bunch of moving parts, and not all of them are very friendly to the limited environment that you get when you're running a Lambda. So first off, devshim. I have no idea how to pronounce that. I have never heard anyone say this word before. Please, please, if you have any comments, I would love to hear how you pronounce it. I'm sure we can be really creative. So what is devshim? So it's a file system that is backed by RAM, which is great if you have lots of code that thinks it needs to write stuff to files, but it really doesn't. They're kind of ephemeral, or they're written constantly, and it's just going to save you a bunch of time because you're just writing it to RAM, and then that's great. It's also used for shared memory functions. So if you're running a certain, like more recent version of Linux, POSIX expects you to be able to use devshim to work with all of their shared memory functions. So shim open, shim unlink, and memory map are some of the calls you can do. So Chrome uses devshim to share some memory between some of its processes. It's not very heavily used because they also have to make it work for all of the other operating systems that they use. So they tried to avoid using it, but they do use it. And what that means is if they realize that you're on a Lambda, or sorry, if they realize that you're in Linux, they will say, well, if devshim doesn't exist, we would like to crash. And because enough people commented, this is a horrible thing, we would like to be able to run stuff in Lambdas, and they don't have that. Or we would like to run Chrome in a Docker container, and devshim is really tiny. Chrome actually created a flag that lets you not use this feature. So you can just say, I don't want to do this. Don't worry about it. Just you pretend that I'm on a Mac or whatever. So that's pretty great. If you complain a lot, sometimes open source will fix your problem for you. Politely complain. So another thing, you've probably seen this if you look at your browser having lots of tabs open. Chrome uses multiprocesses to do a lot of stuff really fast, and that means you can leave your email tab open all day, which is nice. This is great. On a Lambda, you're not restricted to the number of processes you're allowed to create too hard. I think it's something around the order of 1,024 processes, so that's fine. You could have a bunch of tabs open. But the way that all the information is shared between multiprocesses and the way that everything is sandboxed means that you might not want to use multiprocesses on your Lambda. So you might want to say, just use a single process. So the next point, sandboxing. To run JavaScript from other people's computers on your computer, you want to not actually let them do anything crazy, which is great. And over the years, Chrome has really invested in this because it is the most important part of their security protocols for keeping you and your email attachments from giving you terrible viruses. So over the years, but every time the Linux kernel comes up with an improvement that allows you to do something better in the sandboxing process, they will upgrade their code and then maybe not necessarily take out all the checks because they are afraid that sandboxing breaking means that you will have a serious security issue. So there's a bunch of them, and some of them don't work on Lambdas because they don't give you any permissions. So I think previous incarnation to the current one used setting UUIDs to when they were creating the processes. And this does not work with a Lambda because you just don't have any permissions. They try to give you nothing so that it is not a security flaw. So you have a couple options. You can say no sandbox, which means there are no sandboxes, which maybe isn't the best idea, but it is probably the most reliable way to get this to run right now. If you do experiment it, it does work without no sandbox. You are going to want to say disable set UUID sandbox, which is the one that expects permissions, because otherwise it will just hard crash pretty much no matter what immediately. So this is relevant mainly if you decide not to use multiprocesses. Chrome, to set up a new process, creates a process called the Zygote process. So you have the main browser process. It starts a new process, does a bunch of startup tasks, and then anytime you need to launch a new site instance process, it can sort of branch off of the Zygote and have all this pre-done work not have to be repeated. This is totally useless if you choose not to use multiprocessing. So if you choose to have a single process, definitely you got to use this flag because it doesn't make sense. You're going to just do this extra work, but then it doesn't matter. So you actually want to do this. You're ready to go. So you need a piece of, like a build of Chrome that actually can run in a Lambda. You have to use it using, or you have to build it using the target architecture. So you can't run these build instructions on your Mac and then throw them up in a zip, the executable in a zip file on your Linux, on your Lambda. More or less, it's the same process as what Chromium releases and says, this is the build steps. Follow these, you will have a build. This is exciting. Except we do something horrible. Yeah. So what this does is it says, there is a point in the Chromium source code that says, have we had any failures from any of the system calls involved in doing the inter-process communication so that the sandboxed processes can still talk to each other safely? And in the Lambda, when a process, or when your function stops running, they kill all the syscalls that are currently executing. So this crashes what the check is checking for. And then when they next have your implementation, or you next have a function run in the same context, it will unfreeze. So because all this syscall is crashed, Chrome thinks that the conversation between all of its different threads is failing and that everybody needs to freak out and crash immediately, because if you can't talk between processes, then you can't access all sorts of resources. So we just don't let it ever crash. This is going to say, never let that check get to the value that trips the panic. So you've edited the source code. Never do this, but we do it. It's in production. And then you need to install some dependencies. I'm not going to go through them all. It's really not that exciting. They're all mentioned in the Chrome how to build source section. There's also tons of blog posts about how to do exactly what I'm talking about in this talk. And they use slightly different and somewhat non-intersecting set of resources. Play around with it. If you're doing this, definitely commit to using your own build and don't just get the one that people publish on the internet for safety purposes. So the reason that we can actually fit the Chrome binary into that 250 meg limit and also the 50 meg limit of the package is because we're going to build it with as few symbols as possible. We don't want a debug symbol for anything because we're probably not going to look at those anyways, so why do we care? So pretty much every line of this set of settings says, no, don't put settings, or don't put symbols in the binary. So that's pretty easy. The only thing that's not true about is the last line where you see enable NACL false. That's the native client. It is currently only used in Chrome on Android phones. So the Android build needs the native client. I don't really know why they call it the native client if they only use it in one place, but whatever. It's not important. I don't need to know. I'm not going to worry about it. Some of these overlap. The docs are not great about telling you whether you need to run these mutually exclusively or not. If you put them all in, you don't get any symbols. I have not bothered to play around with, what lines of this can I take out? If you take some out and it works, good for you. This is exciting. So basically, you set these functions, or you set these settings, and then run the build exactly with I think they use Ninja, and they just say build, and then you have a build. It will take a while. If you're running it in an EC2 instance, you will want to remember to turn or shut it off at the end, but you can sort of just leave it for a couple hours as it builds. And then you have an executable. When you run the executable in a Lambda, you want to really limit what it's trying to do. You want to tell it, you're in a small box, be careful. Don't bump your elbows. So you might say, I don't want to use the sandbox, which we mentioned. You might want to say, disable the GPU, because Lambda does not provide you access to a GPU, and it does not have any dependencies that any GPU using code might expect to have. So that will crash. You might want to say single process. And you probably want to tell the pop-up blocker to not worry about it so that you can actually interact with those pop-ups in your automation. So you're running Chrome. It takes a while to start up on a Lambda when it only has so much RAM. Do you really have to start it every time? Maybe. So if you're going with AWS, it will freeze the binary or the process at the point that you have stopped executing the function. So, it just stops. And that means that they stop charging you, which is the key part here. So you have a function, you create a process, you freeze the process because the original function stopped executing. And then a new function uses the same context. AWS decides this. And then they just say, OK, process, you're allowed to keep running. Don't worry about it. We didn't stop. You didn't notice what time it is. That's what they mean when people say hot versus cold function. It's what resources are still available and what isn't. The contrast is that AWS has a very different system than Azure and Google. They're always fresh, never frozen. That means that they don't freeze any of the processes that you create. So if you have a Chrome binary running, and then you just execute your function, you've stopped scraping, you're done, they will just keep running that Chrome process, just hanging out and charging you because you're still running code. So you're paying out the nose. So unless you have a high enough level of concurrency that there is always at least one function running, don't do it this way if you're going to run it on not AWS. So with serverless, you also have a couple other notes that I think are interesting and relevant. Because the underlying VM is reused, files that you create stick around between invocations unless you get a cold Lambda, which means that if you create a file, you can tell if it's a cold start. So if you create a file in a specific place every time that you create it, and if it's already there, then you know that it's a hot Lambda, which can be useful for various different pieces of information. Performance-wise, it can be helpful for sending to your metrics situation. It also means that you really have to clean up your files before you exit, because otherwise you just start to fill the drive, and you are relying on AWS to calm down and delete all those files and kill your compute environment. And you have to be really careful because file names can intersect, and resources like this just do not do well with multiple processes talking about the same file. It's just, we've all been there. So what kind of results am I talking about? What did I get? We've been able to scrape more than 20,000 documents from a backlog that we wanted to get, and at the same time maintain a on-demand scraping service for that's triggered by a user signing up for our service. So a user signs up, we say, OK, we need this file, and then we go get it, no problem. The goal is to get it to be as fast as possible so that we can use it to trigger our machine learning models to decide whether the person is a high-risk client or not. But it's pretty low-key maintenance. We barely touch it. It's great. Surprisingly, after I've said all of these don't do this things, it doesn't work that terribly. We do shut down Chrome at the end of a scrape. There's a couple of reasons why, but the important thing is that Chrome can occasionally crash for what feels like no reason after every 5 invocations. This is related to the way that everything is freezing and then not freezing. And it just doesn't work that well. There are ways around it, but I won't go into that right now. We just chose to just completely ignore it because we didn't really care. There's also a memory leak issue. When you shut down Chrome, you don't necessarily shut it down perfectly. Yes, the Google Chrome team created the code that says stop, and it still doesn't quite work because they really weren't engineering it for a Lambda environment. So you get these zombie processes that just take up and never free any of the memory that they should be freeing. So if you are reusing the same environment a lot, or you're doing a heavy scraping load, this can be a pretty big deal. It usually only hits us if we are trying to backpopulate and do a large amount of jobs at once. Overall, this is a great way to learn about lots of things. How Chrome works, how Lambda works, how Linux works. It was a really enjoyable time. In real life, you could do this if you wanted to do all sorts of things. Testing, running JavaScript in your own browser, or your own JavaScript in a browser context. So let's say you want to execute JS in your context of having your email open. You can do it with this. You can do a bunch of web scraping, which is what we were doing. Or you can take screenshots of all sorts of things. And so, yeah, if you're interested in any of those topics, you can definitely try this out. Thank you so much.